metals and their extractions review sheet. Use this to fill in revision notes. Use this if you've missed a lesson. This is just an overview of the topic, metals and their extractions. So to get us started, we're looking at where metals are extracted from. Mainly metals are extracted from ores in the earth crust. So an awful lot of our metals come from the earth's crust. Now they can be extracted in a couple of ways. Electrolysis if they're quite stable reactive metals, and then the reduction of other metals if they're less stable and unreactive. Moving on though, things like gold is found in its native form, so you don't need to remove it from the ore or the earth crust. You can essentially just mine for it and find it because it's very unreactive. When does difficulty in extracting metals recur? It depends on the reactivity series. So if you're quite a reactive metal, it's quite easy to extract it, but then it's expensive, use an awful lot of electricity. Then the less stable ones, less reactive ones, then you'll have to come up with new ideas. Most metals are extracted by a displacement reaction. Displacement reaction means the more reactive metal, so higher up in the reactivity series, will displace a less reactive metal. So aluminium is quite a reactive metal. It's bound at the moment with iron oxide. Aluminium then can be used, because it's more reactive than iron, to extract the iron. So you're then left with iron on its own, which you can use to build, and then aluminium oxide. That is based on a displacement reaction, knowing that aluminium is more reactive. Now, another way that iron can be extracted is in the blast furnace. Okay, so if it comes in iron ore, so something like it's in iron oxide, is extracted from the earth, and you can extract it using a blast furnace. To form a blast furnace, you need 4 raw materials: iron ore, which is the source of iron; coke, which is a fuel, acts as a fuel, and that's essentially just a carbon-based compound; limestone, which removes all impurities, which is a calcium-based compound; and then oxygen, which heats up the furnace, acts as a fuel. So what you do, not acts as a fuel, acts within the fire triangle to make energy from a fuel. So you add the coke and the oxygen together, that makes carbon dioxide and releases an awful lot of energy. Okay, that carbon dioxide is then added to even more coke, so more fuel, and it makes something called carbon monoxide. Okay, then finally the carbon monoxide is added to the iron oxide, the iron in its ore, and you make iron plus carbon dioxide. So a couple of things with this: there's an awful lot of carbon dioxide flying around. Carbon monoxide, again, which is harmful. It happens in 3 stages depending on where you are in the blast furnace. Another way to extract metals from their compounds is to use something called electrolysis. So this is an example of electrolysis off here. Whenever you think of electrolysis, I want you to panic. Positive anode. So the anode is always positive. So as soon as they ask you to label it, they should see something positive. Just panic. Positive anode. Negative is cathode. So you can straight away label the parts of the electrolysis structure. So break down ionic substances using electricity. Now, like you say, opposites attract. So a negative ion will be attracted to the positive anode, and then a positive ion will be attracted to the negative cathode. In this case, it tends to be metals are positive, so they're attracted to the cathode, and non-metals are negative, so they're attracted to the anode. Remember, you don't need to know which is positive or negative. It will be on your list of common ions on the back of the periodic table. You might be asked to do little ionic half equations. So for lead to become an element on its own, no longer an ion. An ion is something with a charge. You just have to add 2 electrons. So you add 2 electrons to it and it becomes lead. Now it's the other way round for something like Br, which is bromine, is negative ion. It needs to lose the electrons. Okay, it needs to lose the electrons to become an element on its own, and that's how that half equation is written out. So this is often described in terms of these ionic symbols are written out in terms of how they react with oxygen or with electrons. So oxidation is the gain of oxygen. That's quite easy to remember. If something's been oxidized, it's gaining oxygen. If something's been reduced, it's losing oxygen. Now, it's the other way round when it comes to electrons. So the oxidation is the loss of electrons. So this has lost electrons. So bromine has been oxidized. And reduction gains electrons, so lead has been reduced. You can remember that by remembering the little rhyme, oil rig. Oxidation is loss, reduction is gain. Okay, and you're just looking at these half equations to work out what they've lost or gained. Now, once these metals are extracted, they can be used for an awful lot of things for us. Now, the main ones that you need to know about are iron, aluminium, copper, and titanium. You need to know their properties. So iron is soft, ductile, shiny, and uses gates, drain pipes, things like that. Aluminium, lightweight and malleable, which means it can be bent. It's used an awful lot in tin cans. Copper is a conductor of electricity, electrical wires. And then titanium is lightweight and stiffness, so it's used in airplanes. The reason it's used in airplanes is it's lightweight. Transition metals then are in the central area of the periodic table between group 2 and group 3, that big block in the middle. You need to know that they can change their charge. So something like iron can have a +2 charge and a +3 charge. That's because it's a transition metal. It can move. They're often coloured compounds and they're really good conductors of heat. Now, often to make metals more viable and to make them cheaper and more usable, we mix them with other elements. Okay, so an alloy is a mixture of 2 or more elements, at least one is a metal. Some examples of alloys, the main one you most probably know is steel, which is iron and another metal added together. It's used in car parts, it's easily pressed into shape. It reduces the cost of just extracting iron, because it's quite a large cost we learn about in the blast furnace, which is this box by here. So it reduces the cost. What factors affect the extraction process? Not just of alloys, but of all metals. How you find the extraction site, not always that easy to find. The transport of whatever you've made, so the transport of the iron ore to the blast furnace. And then often, like we learnt with the blast furnace, an awful lot of carbon dioxide is released.